Okay, everybody, so we're looking at our lesson for today. We're talking about dot plots and outliers. But before we get to that, I want to make sure to help you set up for these notes. I need you to have your digital notebook open in a tab, and I need you to have our Google Classroom open in a tab. That's going to help us out as well. Because in the class, I want to show you where you can find these videos. Have that classroom open. Once you are set up, and if you're in the class, if you're just looking at this video for review, obviously you don't have to worry about it. But if you're currently in the class right now, I want you to start and or finish the warm-up as we wait for everyone else to load in. Okay, now with that said, let's get into it. Today, like I said, we're talking about section 9.2, which is dot plots, outliers, and data distributions. Learning objectives for today, guys. These learning objectives need to go into our digital notebook. We're talking about dot plots, so of course, that's one of our objectives. I can describe data graphically with using dot plots. The second one are the outliers. We're going to learn how to calculate outliers of these data sets. If you need to pause, screenshot, make sure learning objectives are in the notes. I'm going to keep moving on though. We're looking at vocab today. I technically have 5 vocab words. 3 of them are pretty short. They're on the next slide, but 2 of them are right here. So the first one is called dot plot. Dot plot is a data representation that uses a number line and either a bunch of X's, a bunch of dots, or any other symbol to show frequency, to show how many times numbers show up. These are sometimes called line plots. So basically, if you're using a dot to show the frequency of how many numbers, it's a dot plot. If you're using X's, it's a line plot. That's basically it. Now, the outliers that we're going to be calculating today, these are values in a data set that are either much larger or much smaller than most of the values on the set. This has a couple of steps to calculate to make sure that they are outliers, but you calculate them by taking the IQR, multiplying it by 1.5, 1.5, and either adding it to Q3 or subtracting it from Q1. That range that we set up is like your outlier range. If you have anything bigger than that, outlier. If you have anything smaller than that, outlier. And you'll see what I mean with one of our examples today. If you haven't done so already, make sure you get a screenshot of this. This is the first part of our vocab. Next part of the vocab, we're talking about different types of distributions. So we're talking symmetric distributions. We're talking skewed to the left distributions. We're talking skewed to the right distributions. Notice the differences with these distributions. Notice how they look. Notice what's being pulled to the left, to the right, what tends to stay in the middle, where the mode is for all of them. Notice in symmetric, they're all basically the same spot. And it'll be kind of rare to have a perfectly symmetrical distribution, but if your mean, mode, and median are really close together, it's most likely symmetrical. I want to mention this. We saw this last week when we were talking about mean and median, but I want to mention if you're skewed one way or another, your mean is being stretched away from the center because these random values that are so different than most of the values, they really change the mean. They really affect the average. So like we were talking about last week, if you have a data set that's not symmetric, that's not consistent, you want to look at the median for center. But if you are consistent, you want to look for the mean. Make sure you have this screenshot and put into our notes as well. So we have learning objectives. We have the first vocab slide. Now the second vocab slides, we should have 3 screenshots in our digital notebooks. Let's get into some examples. Now, our class activity taught you how to, oh shoot, I forgot. Guys, let me back up a second. So it's kind of tricky to remember skew to the left or skew to the right. Here's how I remember. I always think of them as feet. And as ugly as these feet are, it helps me remember which way is which. Your left foot has big toe on this side, and then your toes get a little smaller as they go to the left. That's a left skew. Right foot, opposite. Your big toes here, and then the toes get smaller on your way to the right. That's a right foot skew, or just skew to the right. So hopefully that helps you remember. Skewed to the left, skewed to the right. Just follow your feet. Now let's get into some examples. So we're looking at example 1 here. We're looking at a few different salaries from this company called Explore, and the owner's salary, which is $150,000. Now, instead of looking at the thousands, we're just going to focus on the first 3 numbers. So, for example, 150,000, I'm shortening down to 150. 25 is really 25,000 a year, but we're just shortening it down to make it easier to work with. So now this list of salaries says 25, 30, 35, 35, 35, 40, 40, 40, 45, 45, 50, 60, and now our 150. With the activity we did in class today with dot plots and learning how to make those, we should be good. We should know how to do this. But whenever you're making those, you want to look for your number line first. Notice we're counting by 5s with all of these numbers. These are all divisible by 5. So I want my number line to do the same thing. My smallest numbers are 25. My largest is a 50. So I have to make sure my number line at least covers those numbers. I'm going to go 20 to 160 just to stretch it a little more. But there's my number line. And every notch in the line is a 5. So this is 20, 25, 30, 35, then 40. Let's start putting the data into our dot plot. Now, technically, this is going to be a line plot because I'm going to use X's instead of dots, but I'm going to put a marker down for each one. So there's my 25 here on 25. I had 130, 3 35s, 3 40s, 2 45s, a 50, 60, and a 150. So the rest of those points look like this. There's my distribution. A big takeaway that should be like immediate. Look how far away this value is from the rest of them. Just visually, it's likely he is an outlier. But let's find out for sure by calculating it. To calculate, we need to find the IQR. So to help us with the IQR, let's find the median first. Now you can find it from the dot plot by counting the values on the outside, the x's, crossing them off till you get to the middle. But we have our numbers right here already ordered. So I'm going to do the same thing. I'm going to cross off 25 and 150, 60 and 30, 35 and 50, and I'm going to work all the way to the middle, which is this 40 right here. So there's my median. This, as the median, means I have 6 values below and 6 values above. Half of 6 is 3, so let's go 1, 2, 3. Okay, I'm between 2 35s. Since it's the same number, I know that Q1 is 35. Do the same thing above it. There's my 40 in the middle. 1, 2, 3, 1, 2, 3. Okay, I'm between 45 and 50. Follow the median rules. If you're ever stuck with 2 in the middle, like our 45 and 50, add them together, divided by 2. 45 plus 50 is 95, divided by 2 gets us 47.5. So there's our quartiles. Now we could subtract them to find the IQR. That IQR, 47.5 minus 35, gets us 12.5. Now we could use that IQR, times it by 1.5, and add it to our Q3, subtract it to our 35, our Q1. So I'm going to move the dot plot away for now because we don't really need it anymore. We have all the information. So we have our IQR of 12.5, times it by 1.5, times it by 1.5. So I get 18.75. Now, looking for outliers, we have to be beyond so much of Q3 and beyond so much of Q1. Since Q3 is bigger, I'm adding that value to it, and I get 66.25. Since Q1 is the lower one, I subtract to see if I could get it much lower, and I get 16.25. So this upper and lower outlier bounds tells me if I'm at this number or in between, I'm not an outlier. But if I'm bigger than 66.25 or if I'm smaller than 16.25, I'm an outlier. So let's go back to the original problem. We're looking at his salary, which is $150,000. Is that more than our 66.25? Well, clearly, yes. And since it is, 150 is now officially an outlier. So a lot of the times you'll be able to see it visually, especially with an example like this. We did the dot plot. We saw how far away that 150 was. It was clearly an outlier. Some other times it's not going to be as easy. For example, what if we had a 67? It would look far away, but is it far away enough? And that turns out it's pretty close. But a 67 would be an outlier because it's more than our upper bound. What if it was a 65? Very close again. Might look far away enough, but turns out it's not because it's inside the 66.25. So that's why we calculated to make sure. Okay, so we took data, made a dot plot, found our median, our Q1, Q3, and an RIQR. So we could multiply it by 1.5 and then add it to our Q3, subtract it to our Q1, find our upper and our lower bounds to figure out if any numbers were above or below. Any of those were outliers. 150 is an outlier. Let's get to our last example, example number 2. For example 2, this time we're going to create dot plots and look at their data distribution shapes. We have in this table miles, 3, 3.5, 4, 4.5, 5, 5.5, 6 miles. And then we have team A and team B. Now it says members. So these numbers must represent how many of their teammates ran this amount of miles, this amount of miles, this amount of miles, so on, so on. So to explain a little more, Team A had 2 teammates run 3 miles. Team A had 4 teammates run 4 miles. 3 run 5 miles. They had nobody. They had 0 run 6 miles. I don't blame them. I don't want to run 6 miles. Team B, same kind of deal. 1 ran 3 miles. 3 ran 4.5 miles. 4 ran 5.5 miles, so on, so on. So now we're going to use this data to make dot plots. The nice thing about this is we already have the number line set up for us. Look how close those numbers are. Look how they're changing from column to column. 3 to 3.5, 3.5 to 4. They're going up by half or 0.5 every time. So let's make our number line match that. We'll go from 3 to 6, counting by halves. Then put dots for each number for how many teammates ran. So for here on team A, I should have 2 dots. Here, I should have 4 dots. And at 6, like we said, 0 dots. Team A's dot plot should look like this. 2 of them for 3, 3 of them for 3.5, 4 for 4, 4 again for 5.5, 3 of them for 5, 2 of them for 5.5. Hopefully you notice something here. We'll talk about it in a second, but hopefully you notice something here. I want to look at Team B. So for Team B, same kind of deal. Put the dots down, and it looks like this. Clearly different shapes. Let's talk about those shapes. So, Team A, does that look like any of your guys' feet? Hopefully not, because that big toe is right smack in the middle of that foot. That's not a normal foot. This is a symmetrical distribution. And actually, this is one of those rare ones I was telling you about because this is like perfectly symmetrical. You draw a line right down the middle here. You have a column of 4, then 3, then 2. Column of 4, then 3, then 2. This is perfectly symmetrical. So there's no denying team A is symmetrical. Now, team B, can you do the same thing? Can you draw a line down the middle and have it be even on both sides? Clearly not. Now, if we're thinking about feet here and we're thinking about skewed, this is the big toe, and it gets smaller towards the left. So this is now left skewed data. And since we're talking about feet, if your second toe is your bigger or bigger than your first toe, doesn't that mean you're going to be a CEO or a manager someday? So if your foot looks something like this one, that's kudos to you. You might be a manager. So we know team A is symmetrical, and we could see that team B is skewed to the left, or what I'm shorthand, left skewed. This means our mode, our median, our mean should all be the same or not close to the same value. Team B, not exactly. Mode is going to be the number that shows up the most, so 5.5. Median's probably a little bit less, probably that 5. And if we calculated mean, we'd probably get around 4.5. Because of this 3, it really pulls that average, that mean, away from the center. That's it for example 2. That's it for the lesson even. So guys, review the video if you have any questions about it. And then if the video is not helping you, you need more, you always know how to reach out to me, email me. What I need you to do after reviewing or before reviewing even, make sure you have the learning objectives, the 2 vocab slides, and the 2 examples in your notes. So either 5 screenshots or like we talked about last week, take write it down in your notes, take a picture of the notes, put it in your notebook. This is going to help you out on Tuesday, which is our first asynchronous day, because I won't be there to help you. We don't have class. So you could use this video to help with that. Thanks, guys. I'll talk to you later.